Have you ever sent an email or watched a video and just stopped to wonder how it actually gets from one side of the world to the other in like less than a second? Well, it's not magic. It's an absolutely incredible physical journey. All right, let's dive into this and uncover how the internet literally travels across the globe.
I mean, we use it every single day, but what is the internet physically? We hear all about the cloud and wireless, but the surprising truth is that the internet's backbone is incredibly real. It's a massive worldwide network of actual physical cables.
So, before any information can even think about starting its journey, it has to be translated. Your computer and the internet itself, they have this secret language they use to communicate with each other. And that language is called binary data. It's so simple, but it's unbelievably powerful. Everything, and I really mean everything, from your text messages to the most complex videos, it all gets broken down into a long string of just two numbers, zeros and ones. So get this, that hilarious cat video you just watched? Well, as far as the internet is concerned, it's not a cat. It's just a gigantic, perfectly organized sequence of zeros and ones that represents every single pixel and every bit of sound. Kind of takes the cute factor down a notch when you think of it that way, huh?
All right, our cat video is now just a string of ones and zeros. So where does it go first? Let's trace its path, starting with the cables that are closest to home.
Okay, so the data's journey has two main characters. You've got your copper cables and your fiber optic cables. For that first short leg of the trip, say from your house to the street, your data travels as electrical signals through old-school copper wires. But for the long haul, it needs to transform into something way faster, pulses of light, traveling through fiber optic cables.
These copper cables are the real workhorses for short distances. They're probably what you have inside your home, connecting your router to the wall. And they carry that binary code as simple electrical signals. An electrical pulse means a 1, and no pulse means a 0. Simple enough.
But here's the big problem. Electricity fades over long distances. It just runs out of steam. So how do we get that cat video from New York all the way to Tokyo in a blink of an eye? Copper cables just won't cut it. We need something much faster and way more efficient.
And the answer is, it's just brilliant. We stop using electricity and we start using the fastest thing in the known universe, light. This right here is the key to the whole thing. For long-distance travel, that binary code of zeros and ones gets converted into pulses of light. A quick flash of light represents a 1, and a moment of darkness represents a 0. And this all happens inside these incredibly thin strands of pure glass called fiber optic cables.
Okay, so we're shooting light down a tiny glass tube. But how does the light not just, leak out? How does it stay perfectly contained while traveling thousands of miles? Well, it's all thanks to a very clever trick of physics.
It's a principle called total internal reflection. And what this does is it basically turns the inside of that glass fiber into a perfect, endless mirror. The light hits the wall of the fiber at just the right angle. It's a very shallow angle, and it has nowhere else to go but to bounce perfectly back inside, and it just keeps on going without losing its way.
So here's how it works. A laser flashes a pulse of light, that's our 1, into the fiber. That little pulse of light then zigzags down the cable, bouncing millions and millions of times without losing hardly any energy until it gets all the way to its destination. It is an unbelievably efficient and fast delivery system.
So now that we know how it works, let's talk about why. Why is light the absolute perfect choice for this job? I mean, why go through all the trouble of converting electricity to light and then back again?
Well, there are three huge reasons. First off, speed. We're talking about data traveling at about 2/3 the speed of light. That is insanely fast. Second, endurance. Unlike electricity, light loses very little signal strength over huge distances. And third, capacity. A single fiber optic cable can carry way more information than a copper wire of the exact same size. It's not even close.
And this just shows you the incredible scale we're talking about. Our global internet is physically held together by hundreds of these massive fiber optic cables that are laid on the ocean floor. Some of them are no thicker than a garden hose, but they carry nearly all of the data traffic between entire continents.
To put it all really simply, think of it like this. Imagine you and a friend are miles apart at night, and you're communicating with a flashlight using Morse code. That's pretty much what fiber optics is doing, just on a microscopic scale, millions of times per second.
The principle really is that simple. In our flashlight analogy, light on means 1, light off means 0. Fiber optics is doing the exact same thing with a tiny little laser. It's just an incredibly fast game of on and off that carries the entire world's information.
So, the next time you stream a movie or video call a friend on the other side of the planet, just remember this. You're actually controlling pulses of light flashing through a massive network of glass fibers buried at the bottom of the sea. The internet isn't in some mysterious cloud. It's light in a cable.